Good afternoon, ladies and gentlemen. My name is Freddie McBride. I'm EENA's Director for Digital Communications Policy and Regulation. We're going to continue the theme of next generation in this last track one session of the day. We're going to focus on location in next generation. We'll take a bit of a deep dive into it. There should be a bit of the theoretical stuff, conceptual level stuff, and practical aspects as well. So I'm delighted to be joined on stage by Michael Prosler, who is CEO of GridGears, by Deepti Bharti, who is Director of Software Engineering Research and Development at Creativity Software, and also by Peter Woodward, who is the Chief Executive Officer of Eli Technologies. You're all very welcome, and thank you for being here today. Okay, our next speaker is Deepti Bharti from Creativity Software, and Deepti is going to talk about location intelligence in next generation. Thank you, Deepti. The floor is yours.
Okay, good evening all. Welcome to this session. Today I'm going to talk about next generation location intelligence in emergency services. I'll start by reiterating what Michael has already mentioned about why location technology, and especially the automatic location information, is so important in emergency communication. Then I'll take you through the various location technology that are working today, especially in Europe. And then we'll talk about how these location technologies would evolve for the next generation emergency services and communication. And if time permits, then I'll also talk about, give you an introduction about Creativity Software, which is the company I work for. Okay, so again, reiterating with what Michael has already mentioned, why location technology is so important. So we need the location information in emergency communication to, first of all, route an emergency call to the right location. By location, I mean to the most nearest and most relevant PSAP. And then also provide the location information of the emergency caller to the PSAP for the emergency dispatch. So it is quite key that the location information is provided quickly, so it is fast. The location information is accurate and also is reliable. So let's start by looking at some of the location technologies that we have today. I'll look at the main mechanisms that are in place. So we'll start by fixed line address lookup and ALI lookup, which is the oldest mechanism that represents a very small number of emergency calls which are made from the PSTN network. The next is mobile network-based location. So all the devices ranging from 2G, 3G, 4G, connecting to these network technologies and a variety of devices. The location information of such devices can be provided and generated by the location network. Then we have AML, and this is the latest mechanism which is used where a smartphone will automatically generate the location using hybrid or GNSS, Wi-Fi, or cell ID based information. And then lastly, we have eCall, which is a system which, when installed in a vehicle, can generate emergency call, can set up a call if that device or that car is involved in an incident, and provide the location information along with minimum set data to the PSAP via the mobile network. So looking at fixed line a bit more, the location, so this is, as I said earlier, this is the oldest location generation mechanism, and the key point here is that the location intelligence is either sitting in the PSAP, which performs a address lookup, or with the PSTN service provider, but there is no information, no location information in the device itself. And from there, we move towards the mobile network, which are, as you may all know, heterogeneous in nature, which means there are different type of network technologies which coexist in most of the mobile networks today. So technologies like 2G, 3G, 4G, IMS, and now even 5G technologies are being deployed in the mobile network. And there are a variety of devices that can connect to this mobile network, ranging from legacy devices to smartphones, even connected cars. So the mobile networks have the capability wherein they can, if required, generate the location, and it would depend upon different mandate and different type of deployments varying from country to country as to what kind of accuracy can be generated from the mobile network. But usually there are two steps that the mobile network performs for an emergency call. So one is when it is setting up the emergency call, it uses the location information to route the call to the right PSAP. Whether it's 2G, 3G network, then the MSC or switch would be used, or if it's a 4G VoLTE-based call, then an eCCF node would be used to establish that call to the PSAPs. And then in the next step, finer location information or detailed location information is provided to the PSAP from the mobile network. It can either be done through a push or a pull method, and that may vary from deployment to deployment. But the crux is that there are nodes, standards-based nodes, which can be deployed in a mobile network, which can provide different type of location information. And just talking about that location information, I just want to highlight here that in most countries, it is mandated that mobile network provide at least cell level accuracy, but that accuracy can vary drastically. So it can be as accurate as 500 meters in a urban area, but that accuracy can go towards in kilometers if we are in a rural area. But nevertheless, there is capability within the network if used. Further high accuracy can also be achieved. There are positioning techniques and positioning methods like assisted GPS, OTDOA, and enhanced cell ID that can be used to provide accuracy which is within the region of 50 meters. So in this case, as we can see, the location intelligence sits in the network. And then let's talk about AML. So we all know that now it is widely used in Europe. It's been deployed in 25 countries worldwide, and it is supported by Google and Apple on their handset OS, and is deployed countrywide, where the smartphone is able to generate its own location or a hybridized location using GNSS, Wi-Fi, and cell ID information, and then can pass that information as part of an SMS to the network and send it to the PSAP. So there are strengths and weaknesses currently to this method, as it relies heavily on handset to obtain the accurate location. There could be scenarios where the handset is not able to latch on to the GPS, maybe because the handset is indoors, or there are issues with the battery that's running on low battery. It could be just that there is not enough data available. And similarly for Wi-Fi, at times the Wi-Fi results can be unreliable. So though this is quite a useful location technique, but I think there is still more room for improvement and to reduce the error rate that we currently see. So let's look at the next generation location technologies. And I'll start by looking at the next generation service landscape. Again, Michael already explained about the ESI network, but the main landscape of next generation introduces the NG112 architecture. And this is the architecture which we understand will enable the modernization of emergency communication, as it will allow more data to be communicated between the handset and the PSAPs, and that data can include text, video, and can also enable, if required, live streaming to be made possible, and which in return will provide more efficient PSAP response to an incident. And then what is going to enable this NG112 architecture? That is going to be the emergency service IP network. So this is going to be the key factor here, that the whole architecture or the whole network is going to be based on IP technology. So this is a big shift from the current infrastructure and technologies that are in use, where a lot of interworking is required and different protocols are used, and a lot of bespoke implementation is done. So with the introduction of ESI net, it will enable the optimization of the emergency communication. And then one of the biggest upcoming changes to the emergency call will be that NG112 will be that it will be able to connect or receive emergency communication from a wide variety of devices and user equipments. It will range from PC and smartphones to IoT devices or to IoT networks which are connected to, say, mobile network through which they can provide or establish emergency communication, to the next generation e-call, where the car is able to establish the signaling and also passes location information via the signaling itself, rather than relying on, say, a modem that currently has to be used for 2G, 3G network. So and what is going to enable all this is, the key point here is that the technology, the underlying technology, which is the SIP protocol, is going to make this end-to-end communication quite seamless, because this will be the protocol which would be supported by the handsets, by the devices, by the network, and also by the PSAPs. So it makes the whole communication seamless and efficient. Now, again, reiterating that the key enablers for this location technology, the first key enabler and the foremost key enabler is IP-based calling and IP-based signaling. This is what is going to allow such a wide variety of devices and applications to connect to NG112 architecture and ESI net. And then I think it is also very important to identify that the next generation of mobile network are also going to play a key role, because with 5G we are already seeing that there are a lot of femtocells and microcells which are being deployed everywhere, and that is going to improve the accuracy. Even the cell level accuracy which we will receive would be much better than what we observe currently. And then, because of the 5G deployment currently, most of the communication service providers are undergoing a huge digital transformation. So the IP was introduced in 4G, but because 4G is backward compatible, quite a lot of operators for emergency services, they use circuit switch fallback. So whenever a 4G subscriber makes an emergency call, that call fallbacks on 2G circuit switch, which means that the value that a 4G could have added by introducing location as part of SIP is not being utilized. But with 5G, we don't have that provision of doing a CS fallback, which means now the operators really have to implement IP-based techniques for emergency services. And then Wi-Fi technology and the maturing of the Wi-Fi technology is also going to be one of the key enablers for this next generation 112 location technology. Talking a bit more about the mobile networks and especially 5G, we have talked about that it is definitely going to improve even the basic cell level accuracy, because there would be more cells which will be installed and deployed in the network. It is also going to improve the rich data that we want to exchange as part of NG112. So with 5G, with low latency and high speed, it will provide the capability that, a lot of videos are sent, live stream data is made possible without interruption or without big delay. So 5G is going to be an enabler for that also. And as such, mobile networks will still act as kind of a fallback option, wherein if for some reason or the other, the device is not able to calculate its location or provide its location information, then mobile networks would still be able to do that. So if you remember at the beginning, I mentioned that emergency location needs to provide fast, accurate, and reliable information. And the way we see this developing is that we see that we'll find that AML will continue to be adopted around the world, and there would be more improvements. And we hope that the errors and things like supporting roaming subscriber would be introduced as part of the AML. Then with with more countries deploying 5G, we will see improvement in the location that is calculated by the mobile network. And as I said, third development would be the other networks like Wi-Fi. There would be more maturity in those networks, so that information like indoor location can be improved using this technology. Even height information and the floor information can be retrieved if this technology is used, or it matures so that it can be used reliably. And then the NG112 architecture, NG112 architecture is going to bring together all the different type of devices that can now establish emergency communications and send their location information in case of any emergency. So this whole, we know that gradually the location intelligence will move completely, more or less, into the devices. But this whole process would be an evolution and not a revolution. It is going to take time, and gradually we will see a shift, majority of the shift, where the devices will be able to send more reliable and accurate location information to the emergency service providers. So that's it on my presentation, and I will quickly give you an overview about my company. So my company's name is Creativity Software. It provides location-based services to mobile network operators and government agencies, and it provides very high accuracy location and location intelligence for emergency services, for law enforcement agencies, and also for monetization and compliance for mobile network. And it was founded in 2001 and our solution has been deployed in many countries, 17 countries, and in multiple continents. That is it from my side. Thank you very much.
Thank you very much. Thank you very much, Deepti. Just when the audience is thinking on questions, I might just make a comment. I like the way you use the term location intelligence and not location information. And the fact that you talk about evolution, not revolution, because really I don't think any single solution is the panacea for location. And we can see that when you have complementary solutions, it's almost like the more you have, the better. You can really, get to a point where you have something that's really reliable. It increases reliability. So,
Yeah.
thank you. Any questions from the audience for Deepti? Yes, Peter.
Thank you. Thanks for the presentation. You mentioned that the coverage of cells in rural areas can be tens of kilometers, and in cities it is a lot less. And in 5G, we will have femtocells and microcells, but do you think that they will also show up in rural areas in 5G?
Well, eventually they will, but that will take time. So first of all, before deploying 5G cell, I would see more coverage provided by 4G. And then once the, we all know that networks are switching off either 2G or 3G technology, which means that 4G technology, first of all, is going to become more prevalent. So that radio coverage would be better, definitely, than 2G, 3G. And in years to come, then yes, even 5G would move towards rural, but initially it will be more focused in cities.
Yeah, because the cells are laid out in rural areas because of coverage, and in municipality areas they are laid out for capacity. So you don't need the microcells in rural areas because you don't need big cells for the coverage.
Yeah, that's correct. But again, with 5G, 5G is, it again depends upon country and mobile network operator as to how they want to utilize or monetize on 5G. They can also provide broadband using 5G, and they can, if they are planning to, roll out connected cars or smart city, then they will have to provide that coverage beyond the cities. So as I said, it will happen, but I don't see that happening in the next couple of years.
Thank you.
Thanks, Peter. Thanks for your answer, Deepti. Any other questions? We still have time for one more, maybe?
Yep, Freddie, over here, thank you.
Oh.
Thank you so much for using Google Maps, and particularly my neighbourhood in and around London. I recognise some of those places, I appreciate that. Mine's a comment, I suppose, rather than a question. I think you're absolutely right to look at the massive flexibility that IP-based networks give you. But there's nothing intrinsic in an IP network to improve location in itself. And I think the focus, as you point out, will be about devices and the device's ability to locate where they are and to then transmit that information across IP networks. So I think the important point is to say that there's nothing in the network itself, because it's IP, that improves location accuracy.
Yes, that's correct. So, as location information as part of the emergency communication, yes, accuracy is one aspect, but reliably forwarding that information and making that communication fast is also very important. So IP will provide that, but yes, device itself, the location information will have to be within the device, and the mobile networks, can provide that fallback if for some reason that device is not able to calculate the location, or in some scenarios, network operators can also validate that location, whether that location is correct or not. Yeah.
Okay. Anyone else? No? Okay, Deepti, thank you very much. Actually, you did make another good point about the circuit switch fallback, and when 4G is gone, that's gone. So we'll have to move to an IP-based network at that stage. Okay, thank you. And so that just leaves me to say a big thank you to our speakers in this particular session, to Michael Prosler, to Deepti Bharti, and Peter Woodford. If you'd show your appreciation for them, please. Thank you.